Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi. Waalaikumsalam, sir.
Okay, how are you? Everybody okay? All right. Today I will finish up, hopefully, chapter 9, and then we will move on to chapter number 10. What I will do, we will finish up the first derivative, in chapter number 9, you'll see the higher order derivative. So that one we will do later. What I will do today, I will go to finish the application, and then we're going to look at the, the first derivative test. What it means basically is we're going to relate the derivative and the function. How the the behavior of the derivative determine the behavior of the function. That's what we would like to do. Or in other words, how does the derivative relate to the function? Okay, so let's look at application. Now you go back to 9.4, 9.5. We'll see the derivative, the application mainly would be on the on the marginal. Okay, the derivative, we are looking at the marginal. Is this our class? Saya pun kadang lupa dah. Because I have 2 classes. All right, so if you look at the application, our plan, we're going to finish up chapter number 9. We're going to do application, okay, of the first derivative, and then we're going to relate, okay, f prime of x to the function. So this is, sometimes we call it first derivative test. So we're going to do this one. All right. Now go to 9.4. Application is basically this. You have dy dx, which is, before we do that, let begin nicely. Okay, if you consider a function y equal to f of x, you have the derivative, which is y prime equal to dy dx. So this is the application, all right? The derivative, which is y prime, and then we are going to look at dy dx because that's how it relates to the slope, okay, to the slope. So let's look at a few applications. Now, number 1, I think we go to 9.4. Go to the book. Look at the book, 9.4, 9.5. If you look at the 9.4, 9.5, 9.6, applications are the same. It's just that we are applying the different rules. So we go to the basic one, the basic would be, I think, 9.5, where we use the product rule and the quotient rule. That's where we have the application. Okay, application number 1. We go to example number 4. All right, that is on the marginal revenue. And then we look at marginal cost. Marginal cost ada. I thought there was examples on the marginal cost. So then you use the derivative, higher order derivative, I think application dia 9.9. Okay, 9.9 lebih banyak application. So we will start with 9.5. Correct? Now the first example is example number 4. That is on the marginal revenue. So we know this already, all right? Because from the linear function, you have marginal revenue and then the marginal cost, marginal profit, things like that. So the application will be similar. So the application in general, you have, marginal cost, you have the marginal profit. What else? What are the marginals? So we are going to use the same approach, all right? So the derivative would be the marginals for the function. So derivative, in application would be the marginals. So that concept, all right, we already have the foundation from the first topic where you have revenue function for linear function, and then the slope m is the derivative. Not the derivative, the slope is the marginal revenue. So based on what we learned for the linear function. So example, all right, for the revenue, you have revenue equal to Px. And then what is the slope? The slope is equal to P, and of course that is equal to delta R over delta X. So we know that that is the marginal revenue. So this is the base, all right? So we are going to apply derivative to the revenue function, and the derivative would also be the marginal revenue. Why? Because we define derivative as what? As the slope at a point, okay? As a slope of a function at a point. So it's basically slope, okay? It's slope. So that's the marginal. So if you look at example number 5, given the revenue function, all right? Revenue function equal to R, f of x, function of x. Then what? Then what is the derivative of the revenue? You call it R prime, which is f prime, which is dr dx. So that is the marginal revenue. So it's the derivative of the function. Now is the marginal revenue. Okay? Now similarly for the cost, if I have a cost, all right, cost is also a function of x, then the derivative of the cost is what? C prime, which is equal to dc dx. So that is the marginal cost. All right, so the derivative, we use the concept of the slope at the point. So the derivative is the marginal, okay? The marginal revenue, marginal cost. Or if you look at profit, we know the profit is a function of x. Then what is marginal profit? P prime. And that is what? dp dx. So that is the marginal profit. So derivative is marginal, whatever the function is, right? So look at example number 5. You have the revenue equal to what? R equal to 10x plus whatever the second term is. So now you want to find the marginal revenue. So what do we do? Ni anak-anak, cucu-cucu, can you please go? I have a class. Okay? Please quiet. Diam sikit. Okay. Sorry. Cucu saya ada datang sini. Alright. So now the marginal revenue is what? So you want to find the marginal revenue, that is what? That is R prime equals what? Now you apply the rules. Whatever rules that you learned earlier, apply to the function, and then you get the derivative. So how do you differentiate the first term? What is it equal to? It's just 10, okay? Plus. Now the second term is what? 100x over 3x plus 5. So how do you differentiate that? The second term is a little bit difficult. So how do you differentiate the second term?
Use the formula.
Use the formula for what? Which rule is this?
Quotient rule.
You use the quotient rule. All right. So you let u be equal to, now let that term, you have to put aside and do it just for yourself so that you get the derivative. So let u be equal to 100x. And then u prime is equal to 100. And then v is the denominator, 3x plus 5. And then v prime is equal to 3. So simple, simple terms. So you apply the quotient rule, and that will be equal to, just call it f prime, right, for that second term. So what is it? You have u prime minus v prime over u, everything v squared. So you put in everything. Is this right? Check again the formula. Okay. So you got 100 multiplied by v, which is 3x plus 5, minus, okay, v prime 3 multiplied by u, which is 100x, everything divided by v squared, which is 3x squared, 3x plus 5 squared. Okay, so that is the derivative. Maybe you can simplify the numerator, all right? So we can do that. So what is it equal to? Now it's equal to 100 under 10 plus. Okay, you put in the numbers over there. You have 300x. Is that right? 300x. The other side you got 300x. So that one will cancel out. So what do we have left? We have 500. So 500 divided by 13x. Not 13, that is 3x. 3x plus 5 squared. So here you can simplify. All right. If we just want to use the rule, then you don't have to simplify. But here we don't end with the rule. We end with what? We end with you have to find something else. So in that case, it's good to simplify. You simplify that thing, you have this form. So that expression will give you the marginal revenue. Of course, you can simplify. If you look at the book, you can factor out the 3x plus 5 squared, but I don't think we need that. So I think we can stop here. Okay? So that is the marginal revenue. So if you look at part B, what does it say? It says find the marginal revenue at x equal to 15. So how do you do that? Okay, you want to find the marginal revenue when x equal to 15. All right, how? Where do you put the x equal to 15 into? Will it into the revenue function, or will it be into the marginal revenue function?
Marginal revenue.
Masuk dalam marginal revenue lah, because you want to find the marginal revenue. All right. So you use the substitution method. So you substitute the value, which is x equal to 15, into the marginal revenue. Okay, in order for you to find the marginal revenue. So what is the marginal revenue? Equal to, you see there, 110 plus 500, okay, divided by x squared. So x squared, 3x plus 5. So I have 315, okay, 315 plus 5 squared. So you simplify, if you look at the book, we will see we get the value 10.2. So the marginal revenue, all right, so we can say that the marginal revenue at x equal to 15 is 10/2. Okay, now what is that marginal revenue? What do we mean by marginal revenue at x equal to 15? So the second part is, how do you interpret the value? Okay, how do you interpret the marginal revenue? So in order to interpret the marginal revenue, you have to go back to the slope concept. Okay, now as you recall, if our revenue for the linear function, okay, R equal to Px, you got the M equal to P, and suppose the M, which is equal to delta R over delta X, right, equal to 10.2. Same value as that example. So given this, okay, for the linear function, how do you interpret the marginal revenue? Anybody still remember how?
If revenue increased by 1 unit, the revenue increased by 10.2.
Again, repeat. I think something you make a mistake there. Go.
Yeah.
Sekali. Another time.
Apa tuh sih? If the quantity increased by 1 unit,
if the quantity increased by 1 unit, the revenue will go up by 10.2 unit.
Yes.
Dollars. Okay. So that is how you interpret the marginal revenue as per the linear function. So that is the basic. Okay. That's the basic of interpretation. So if you can do that interpretation, the basic one, then we can do the one that we use for the derivative. Okay, because you start with the basic. So for the derivative, you have the marginal revenue, and that marginal revenue is equal to what? The idea is marginal revenue is equal to dr dx. Okay, another notation for the marginal revenue, dr dx, or you can use r prime. But in order for you to interpret the marginal revenue, you have to look at what? The RDX, so that you can see the change, okay, the ratio of the change. So think of the RDX as what? As delta R over delta X. Okay, remember for the derivative, we are talking about what? We are talking about very small change in X. Now, in real life or in application, we don't have very small change. Okay, we don't have very small change. What is the smallest change in reality? If you sell something, or if you produce something, what is your smallest change? Let's say you sell bottles of water, or you sell appambane, or you sell burger. What is the smallest change that you can have?
One
unit. Okay, 1 unit. Either whatever the unit is, if the water means 1 bottle, if oil maybe 1 kilogram, but you don't have change in real examples, 0.00001 kilogram. All right, no, you have a basic unit. So the basic unit is 1 unit change in X. Okay, so we'll just say 1 unit increase in X. So of course it can be a decrease, okay? But we just, for now, we look at an increase. So the basic unit of the change in X is 1 unit. So we're going to make use of this concept, all right, to describe the marginal when we obtain it through the derivative. So interpretation will be just use the basic one. Okay, so that is the basic, so very important. So if you look at this value here, the marginal revenue where you get it from the derivative, which is equal to dr dx, okay? So how do you interpret it? You interpret it by using this thing here. So how do you interpret it? If X increases by 1 unit, then what happened to the revenue? Revenue will increase by 10.2, okay? So if you look at that example, they don't give you the unit, so we just use the basic interpretation. So like our friend was saying, you have what? You have if X increases by 1 unit, all right, the revenue will increase by, no, this is estimate by about, but you don't have to say about, you just say by the number, by $10.2. But now, okay, now, the function that you have here is non-linear, okay? The basic interpretation is linear function, but what we have here is non-linear. So if you look at part B, the example they give you is X equal to 15. Now, find the value of the marginal revenue if X equal to, say, 1. Okay, what is the marginal revenue at X equal to 1? do it quickly. I give you a small number, because easier for you to compute. So what is the value? If it is 1, then the denominator becomes just 8 squared. So 8 squared is 64. 64, you divide 500 divided by 64. Okay. Anybody get the value? Can anybody first get it? Let me know.
17.81.
17.81. So here, marginal revenue, I put the RDX is equal to 17.81. You see here, the marginal revenue is not the same. Okay, for linear function, it's the same because slope is the same everywhere. But this is non-linear. In non-linear function, the slope is different everywhere. Okay, you can try x equal to 20, you'll see a different value of r prime. So now, if I just say here, maybe it's not that accurate. So now what is the factor that change or that give you the different value of the derivative? What is the thing that give you the different value of the derivative? What is that factor that you need to consider, when you describe the derivative as the slope? What is it that give you a different value?
X.
The x lah. Okay, the one that give you different value is the x. Okay, so now what you need to do here is you have to mention where is the derivative taken at. So here we just add another statement. When x equal to 15. Okay, so because why? Because at the different point of x or different value of x, the derivative will be the same, will be different. That means the marginal revenue would be different. So you have to add, okay, another statement when x equal to 15. That means where do we take the derivative? Okay, so the interpretation will be just similar to the linear function, all right? And we use the derivative to estimate that value, all right? So the way we describe it, just the same as what we have earlier. The only difference is what? When x equal to 15. So here, what is important is the point of derivative. Okay, we have to mention the point where we take the derivative at. So for example, okay, another example will be at x equal to 1, here the marginal revenue is 17.81. So how do you interpret that value?
If x increased by 1 unit, revenue increased by $17.81 when x equals to 1.
When x equal to 1. So you have to mention the point of the derivative, where you take the derivative at. All right. Or, okay, or that's the concept. Or what you can say is that if x increases by 1 unit, that means it's revenue. So if I sell 1 more unit, okay, if I sell 1 more unit of the good, okay, one more unit of the good x, because they didn't mention what is x, 1 more unit of x, the revenue will increase by $10.2. All right, given currently we are selling, okay, given currently I sell 15 units. Okay, currently I sell 15 units. So when I sell 1 more, that means that is the 16 unit. Then what happened? Then my revenue will increase by how much? 10.20. 10.20. But you don't have to say when currently I sell 15 units. I think just make it simple. Just say when x equal to 15 or x equal to 15 or x equal to 1 or wherever we take the derivative at. Okay, is that clear? Any question about this? Now, interpretation, okay? Interpretation is very important. So we look at 9.5, you have the marginal revenue, the example. I give you some questions, right? Some questions. So the interpretation will be similar to that, eh? For 9.5 application, they give you revenue. So revenue, I give you one more question. That is question number 42 and 43. So here, basically, it's not so much of the revenue when I give you two questions, but more of what? More of number one, you apply the different rules. Okay. Sometimes you use the quotient rule, sometimes you use the product rule, and then the interpretation. Okay. So more here, okay, how you apply the different rules, and also the interpretation. So that is important. And then number 48. Okay, 48 is on the advertising. So I give you 42, 43, and then the advertising. I think that will be it. That's good enough. Okay, now go on to 9.6. Is there any application 9.6? If you look at the application in 9.6, basically the length and the width. Okay, don't worry about that thing. So 9.6, we don't look at the application. Okay, 9.7. 9.7 pun tak ada. Revenue. Again here, revenue. So you look at 9.7, the application is still on the revenue. Okay, the example number 4, but you have a different types of function. So just do that example. So now we go to 9.9. Okay, 9.9, they have a more formal discussion of the application. So like I said earlier, if you look at 9.9, the marginal revenue, okay, derivative of the revenue will be the marginal revenue. And then you have the cost, derivative is marginal cost. And then what else? And then you have profit, marginal profit. So we have talked about the revenue. Now what I would like to look at is example number 1. So you look at example number 1 in 9.9. Here, we know revenue is equal to PX. Now, when the price is given, okay, number 1, the price is given, you have perfect competition, right? P equal to 50, so revenue equal to 50x. Now, this kind of market, you call it competitive market. Perfect competition, okay, competition, perfect competition. Okay, now, number 2, the price is not given. Okay, the price is not constant. Okay, and the price is variable. So price variable. Now, when you have this case here, you call the market as monopoly. All right. So when the price is a variable, then the revenue will not be linear function. Okay. So you have revenue equal to PX. Now that P is a variable, it's no more constant. So you have a non-linear function. Now what is P? Okay, what is P? P is given by the demand function. Okay, so you will know P by the demand function. So if you look at that example number 1 in 9.9, you are given what? You are given the demand for the product is equal to what? Demand is equal to
16 minus
0.02x. Okay, so here the demand function is P function of x. Or we can use Q sometimes, depending on the book. So either we use X or Q, but the important thing here is the price is a variable. All right, so you have a monopoly market. So you make use of the demand function to get the revenue. So that will be equal to 16 minus 0.02x multiplied by x. So what do I get? I get 16x minus 0.02x to the power of 2. So I have a non-linear revenue function. So that would be, of course, the function is given there. And then you take the marginal revenue, you differentiate that function, what do you get? You will get 14.4 at x equal to 40. So you have the marginal revenue, and then you can interpret. Okay, so that is the first one. Now look at example number 3. Example number 3, you have the cost function. All right. So cost function, given the cost function, it doesn't matter whether you are competitive or you are monopoly. All right. The cost, you as we know, variable cost plus fixed cost. Or sometimes, they already give you the form. So you look at example number 3. You have what? You have the cost function given as the cubic function. And then here, okay? Here it's good because you have already the product. So here you identify the good, the X, in terms of the output. So what is X? X is the blender. Okay? Blender. What is the unit for blender? Just call it unit. Okay, 1 unit of blender. And then I have what? I have the cost, which is C, that is equal to what? Equal to the dollars. Cost in dollars. All right. Now here, I would like to make a comment about the homework question. The homework question, I give you the break even. So here I will diverge a little bit. Divert. We move away from something that we were talking about. Kita panggil apa? Diverge. Saya pun tak ingat. Check the word. Is it a divert? Or is it a diverge? Or is it something else? I didn't remember the word. We move away from our main discussion to something else. Divert lah. Divert. So I divert a little bit. You go back to the homework. Number 1, the cost function. Okay, here. This is one common mistake that you do. You know the function y as a function of x, and that is, of course, equal to mx plus b. Now, when you talk about cost, you have to mention explicitly. Cost is what? Cost is c equal to mx plus b, where c is the cost. I think I mentioned this when we discussed the homework. And x is the quantity, whatever the quantity is. So when you find the m, all right, when you find the m, you don't use y2 minus y1 over x2 minus x1. You should use what? If you use y2 minus y1, you should write another one, c2 minus c1, x2 minus x1. Now, one problem with you, not all of you, some people, you find the function in terms of y1 and x1, you got it, and then suddenly you have the cost equal to, say, 20.1 x plus 200. And, you have everything that in terms of y and x. And then when you write the cost function, you just do it like that. Now, that is not the right thing to do, okay? Because in the application, you have to at least specify at the beginning, okay? C is the cost, X the quantity, and then you find the function in terms of C and X, and then you got Y as a function of X, and then you write C equal to whatever. So that is not right, okay? I think I discussed that, and I see a few people doing it. So please, okay, go back to your homework. When you do the application, you have to put the function in terms of the application. Even if you use y, it doesn't matter if you use y or x. If you use y, you have to put y. What is y? Y is the cost in dollars. So you have to specify that thing, okay? And then x is the output in units. So it doesn't matter you use y or x, you use c or x, you use z or x, doesn't matter. What matters is that we have to specify, okay? And then you have to, don't just change, all right? Don't just change. You have to explain. You have to explain. Don't just change. You find the function y in terms of x, and then suddenly at the end you give me the cost function. How do you get it? So, So make sure if you did this error, make sure you understand, all right? And don't do it again. Okay. So that is the homework. I think we discussed the homework already. But this one, you know, when I saw many of your work, I need to mention. Okay, so you have the marginal cost. Okay, if you look at the function is cubic function, so you get the marginal cost. Just look at the example. All right, we don't have to compute because the function is easy. So you have the marginal cost, okay, C prime, which is equal to the marginal cost equal to whatever the function is. Please look at the book. And then at part B, you want to find the marginal cost at x equal to 80. Okay, x equal to 80, what is the marginal cost? So what do? We substitute, all right? Substitute x equal to 80 into the marginal cost. All right, now when you do that substitution, the marginal cost will be equal to what? You look at the book. Equal to, you put in 80, so what do we get? We get equal to C prime. That is equal to, you know, work it out. You got 3.2. Okay. All right. Now, interpret. So interpretation will be just similar to what we were doing for the revenue. Okay. So again here, this MC, C prime, what is it? It's DC dx. All right. So when you interpret, you make use of the delta C over delta X. We are talking about per unit, all right? Per unit. So now, interpret. Anybody who can do that? If you got it wrong, that's fine, you know? Okay, describe it. Okay, back. Anybody?
If output increase by 80, the cost will decrease by 3.2.
All right. So I will write down here. If output increases by 80 units of blenders, revenue would decrease.
Will decrease.
Will decrease by 3.2. Okay, is that right or is it wrong? There are 50, at least 50 more people here. Is it right? Is it wrong? If it is right, then you agree. If it is not right, give me the alternative one. Hey, cepat, cepat. I have 87 participants. All right. Now, takkan 86 tu tak tahu apa. Okay, but is it right or is it wrong?
Correct,
Oh.
sir.
Huh?
Betul, betul.
Betul. Anybody who say wrong? Akmal Haziq.
Yes, sir.
Huh? No,
Yes.
check again. What's wrong with you? Okay, Siti Nur Farah. Is it wrong? Is it right?
It's right.
Huh? Apa hal ni? What happened to you?
Sir,
Wrong,
the cost
sir.
will
Wrong.
increase by 3.2.
You know, what are you? Are you dreaming or what? Okay, somebody make the correction. Okay, siapa tadi? Who was the last who talked? Kita tengok nama. Apa? Okay. Give me the correction.
If output increase by 80 units, costs will increase by $3.2.
If output increases by 80 unit, cost will what?
Increase.
Will increase by 3.2. Now we are moving in the right direction. Betul lah ni. It's not the revenue, it's decreases. We are talking about what? We're talking about the cost function. So we talk about the cost function. What is it? It's the cost. So it's marginal cost. So therefore, it is what? It's the value is 3.2. So it will be something to do with cost, not revenue. Okay? So that is wrong. So it should be cost. Now, is there any part of it is wrong? Anybody else? Go back to the first example I was discussing, the marginal revenue, and compare to what we were doing here. Is there anything else that is not right? This is still wrong. This is still wrong. But of course, not that much wrong, but still wrong.
By 80 units, sir.
So what is the right one?
If output increase by 1 unit,
So
cost
the
will
output
increase by
increase,
3.2.
okay, the other one is if output increases by 1 unit, okay, the unit of change of X is 1, okay, 1 unit, not by 80 units. But 80 units is what? 80 units is where you take the derivative at, okay? So if output increases by 1 unit, cost will increase by $3.2, okay, units, dollars. So how does the 80 come in?
When X equal to 80.
When X equal to 80. Okay, so we all have to mention the point of the derivative. Okay, that's good. All right, we started with the wrong one. Now we got it right. So the correction here is the point of derivative is not the increase in the output, or it's not the increase in the X. Okay, it's the point of derivative. So here is where you take the derivative. Okay, so the point of derivative, that means where you take the marginal cost at. But when you look at the interpretation, the X increases by 1 unit. Okay, just go back to the basic. So if the output increases by 1 unit, the cost will increase by the marginal cost, okay, or the slope, which is 3.2. So cost increases by 3.2. But you have to mention when did you take the derivative at, where you take the derivative at. So when X equal to 80 units. Okay, is that clear? Any question about this? So we can make it more specific. So you can say if blenders, if the blenders increases, if you can use the word blender, okay? If production of blender increases by 1 unit, all right, blender, then the cost will increase by $3.2, given X equal to 80 units. Okay, all right. Any question? Okay, by now I think you should we should get this correct already. So look at 200. At that question, part B, you also see at X equal to 200. Now, what is the marginal cost? Marginal cost is 32. So how do you interpret that? Anybody?
Sir,
Yeah, okay, go ahead.
can I try, sir?
Yeah, sure. No, anybody can try.
The interpretation.
Yes,
Interpretation, right?
Yeah, betul.
If blender increase by 1 unit, the cost will increase by 32 when X is 200 units.
That's good. Okay, so that's it. If I produce 1 more unit of blender, the cost will increase by $32. Where? At X equal to 200 units. Or you can just say, but for this thing, you have to mention the blender lah, because we're talking about specific good, all right? So if blender increase by 1 unit, or if I produce 1 more unit of blender, the cost will increase by $32, given x equal to 800, or just say when x equal to 200. So here, because the function is non-linear, all right, the value of the derivative or the slope at different point would be different. So that's why you need to put in, or you need to specify the value of the x, where you take the derivative at, all right? Because when, as you see here, x equal to the 32, marginal cost is 3.2. X equal to 200, marginal cost dah naik berapa? 32, 32. Okay, so you have to state the point of the derivative. So that is example number 2, that is the marginal cost. Now you look at example number 5, is marginal profit. So marginal profit, I want you to go home and just read. Okay, so marginal profit, example 5. So based on the marginal revenue, marginal cost, you go home, read that part. So marginal profit, I have here example 5, example 6, example number 7. So you don't have to actually go into 7 and just look at 5. All right. Because the profit we will, yeah, I think maybe I need to introduce to you the profit also. Okay. You will do this. Okay, I want you just to read example 5. I will go to example number 6. Oh, here again, we just introduced the concept of profit in perfect competition and in monopoly. So can you read example number 6? Just read example 6 for a few minutes. Okay. So what this is you have in example 6 the profit in perfect competition, and then example number 7 profit in monopoly. So the difference would be, okay, the difference will be in terms of the revenue function. Okay, in terms of the revenue function. So you look at the profit. Number 1, example 6. All right. So here is example 6. Perfect competition. You know, it's competition market. You have here the difference is only the revenue. So profit is equal to revenue minus cost. Okay, the cost is normally given. So you see here the cost is given, and the firm is selling the product at $200. So what is revenue? Revenue is equal to PX equal to 200X. So price is given, so you have a linear function here. All right. Now, if you look at the cost, you need to find the cost. What is cost? Cost is equal to, you are given cost per unit. So how do you get the cost? Cost per unit is 80. So cost per unit is the average cost. All right, it's equal to 80 plus X. Now, what I want is cost. So how do you get cost? How do you get cost from average cost? Okay, average cost is equal to what? If you want to find average cost from cost, okay, average cost, you are given the cost function, and then you find the average cost. How do you find the average cost?
Divide by X.
Divide by X. Okay, now if you are given the average cost, you want to find C, what do you do?
Multiply
by X. Okay, so the average cost, you multiply by X, you get the cost. So from here, all right, given the average cost 80 plus X, so therefore cost is equal to 80 plus X multiplied by X. So here again, you know, you make use of the simple relationship, which we already know. Okay, how do you get the average? Average is the total divided by the quantity, whatever the variable is. All right. So you want to find the variable, you have to multiply the average with the quantity. So I have here 80x plus x squared. So our profit P be equal to what? Be equal to 200x minus the cost, which is 80x plus x squared. So that is the profit for the perfect computation. That is example number 6. Okay, I think you finish up, you read at home. Now, for monopoly, you will see that the profit will not be linear. Why? Because the revenue is not linear. All right. So now let's go back to the example 7. They don't give you the function. They give you only the curve. So let's go back to the previous example. The marginal revenue. You are given the profit, the demand function. Okay, go to example number 1. Now in monopoly, okay, in monopoly, the profit is still equal to revenue minus cost, everything the same. But now the price is a variable, okay? So go back to example number 1, you have the price given, which is the demand function, 16 minus 0.02x, you have the revenue equal to 16 minus 0.02x. So refer back to example number 1, okay? And then I will just write down here the profit. So you got the revenue, okay? So I write down the revenue function here, which is 16x minus 0.02x squared. So that is my revenue. Go back to example number 1, we did that earlier, minus the cost. Now the cost can be the same, okay? Whether it is a perfect competitive market or monopoly market. So let's say we keep the same cost function. So given the same cost function, you subtract 80x plus x squared. All right. So what you can see here is the I'm sorry, this is not revenue, that's profit. The profit for the monopoly and the perfect competition, the difference is what? The difference is on the revenue. Of course, cost is also different. But cost, normally, it's either average cost, you find the cost, things like that, okay? Variable cost, fixed cost. But for the revenue, the price is the key, all right? For perfect competition, the price is a constant. In monopoly, the price is a variable, which you get from the demand function. So as you can see here, given the cost function the same, all right? You will see the revenue will be different, so you get a different profit function. Okay, so that is example number 7. So example number 7, I just want to mention the difference in the profit function for the monopoly and for the perfect competition. So what you can do, I don't think what you can do, just find the marginal profit lah. Okay, marginal profit for the perfect competition and then for the monopoly. So you find perfect competition, macam mana, what is the marginal profit, and then the marginal profit for the monopoly based on the function that you have here. Okay, that one you do at home. All right, so do at home. And then interpret juga. Okay, good. So we are done with the application. All right, chapter number 9. Now the other part would be the higher order derivative. Higher order derivative is the second derivative, the third derivative, whatever. So in other words, if you consider your family, if your parents, the function, you are the derivative, your children is the second derivative. That means the grandchildren of your parents. So grandchildren is the second derivative. Okay, all right. So we do that later. What I want to do now, okay, we want to do the relationship between the derivative and the function. So given the function equal y equal to f of x, now what you want to see here, how Okay, y prime relate to y. All right. So let's consider one function, and we will do this. We will do a certain relationship. So given, okay, so basically what you want to do, given the behavior of this y prime, we can determine the behavior of the function, the behavior of y. And when you know the behavior of the y, we can sketch the graph. Okay, we can sketch the line, the curve. Okay, we can sketch the curve. And then you can see maximum minimum. Okay, all right, good. So we do it now. Now look at the function. I'll give you an example. Look at the function, say something like this. All right, this is x, y. This is y is a function of x. So given the function, I want to do this, all right? I want to look at the values of y prime. Okay, the values of y prime. And then you can break the values into intervals. Okay, so let's do that. I'll give you the idea here. Okay, if you look at on the right side of the origin, what can you say about the derivative over here, the slope at the points? Okay, what can you say about the slope here? Y prime or dy dx? Or what can you say about the derivative? Okay, I draw the graph. I draw the straight line there. What can you say about the derivative where I draw in red? What is the characteristic of that derivative or the slope at those points? And then I give you here. Okay, look at the other side. Okay, these are the slopes at this point. Okay, what can you say about the slope here and the slope over there? Cepatlah. Hentam je, cakap je. Anybody? You see it?
The
Describe.
slope decreases, a minimum point, and then increases.
Okay, now you are going too far. Okay, that is the second step. The first step, before you say increases and then increases, that's right. Okay, but give me a more general description. Okay, a more general descriptive of the slope.
Constant.
Is it constant? No, it's not a constant because you see here the slope here is different. So the slope is not a constant, all right? So here slope is a variable. Slope is different. Okay, slope is different. That means dy dx will be different everywhere. Okay, so what else?
Positive, negative.
Positive, negative. So we look at here, the slopes are positive. Dy dx bigger than 0, positive. What about here? Here, dy dx is what? It's negative. Okay, of course, the value is different. Here is, okay, now you know it's positive. Okay, now you go one step further. What can you say about the slope here and the slope over there? And here, then you say what? You say it is increasing. the slope is positive and it's get more steeper. Okay, all right. And if you look at the slope over here, okay, it's negative. Okay, and it is what? In terms of the absolute value, you'll see the function in terms of the absolute value of the derivative or the slope, it's what? It's getting flatter. Okay, or if it is in terms of just a negative value, it's getting higher. Okay, but we just look at the steepness. So anyhow, what is more important now is positive, negative. Okay, this is negative, that's positive. Okay, now when the slope or the derivative change the sign from negative to positive, it will pass through normally. Okay, pass through somewhere here where the slope is equal to 0. Okay, slope is equal to 0. Now I can draw another graph. Okay, if I draw another graph, it look like this. You see the same behavior. All right, you will see here the slope is 0. What about on the right hand side, left hand side here? What is the sign of the derivative on the left here?
Positive.
Positive. Okay, and on the right side, negative. Okay, so that is the behavior of, or the signs, okay, the signs of the derivative for a function, or we can say the slope at a point. All right, it is either positive, negative, or 0. And of course, there will be some point where it is undefined. Okay, you also have dy dx undefined. Okay, but now we don't worry about this. Okay, we make our life difficult if it is undefined. We just look at the one that is defined. Okay, undefined, come back later on, you know, we can see where the situation is, but it's not important to us. So this is it. Okay, so what we do here, for a given function, the derivative can be either positive, 0, or negative. Okay, so what we do here is we break into interval. All right, so you break into intervals where the y prime, okay, based on the y prime or f prime equal to y prime equal to dy dx. Positive, okay, negative, and 0. Okay, so that would be the interval, and this would be the basis of the interval. So go back to the graph. Okay, where is the point where the derivative is 0? I draw the graph nicely here. Where is the point?
Maximum and minimum.
No, I'm not saying maximum or minimum. Where is the point? At what value of x? Where
0.
the 0. Okay, so for that example, dy dx is equal to 0, x equal to 0. So this one, you know, x equal to 0 is a point. It's not interval. So based on that point, okay, based on that point, as you can see, that will separate the positive derivative or the positive slope and the negative slope. Similarly for the blue line, y equal to 0, it occur at the point x equal to 0. And then what happened? You will see on the right, on the left, negative slope, on the right, I'm sorry, on the left positive slope, on the right negative slope. So the one point that break the function into interval would be where the x, the dy dx equal to 0. Okay, so here x equal to 0. So therefore, you break down the intervals based on this point. Okay, so that is the basis for intervals. the dy dx equal to 0. So if you do that based on that interval, then you can break out the interval into two. One is where the dy dx is positive, and the other one is what? Negative. So go back to the first graph, the one that is going up, the black line. Now, where is the interval? Which interval does or do the derivative or the slopes at the point or y prime positive? What interval will that be? Is it to the right of 0 or is it to the left of 0? For the black line, for this one. Okay, you have the positive slope here, dy dx positive. Now, where do on which side of the function, all right, the slopes are positive? The right or
Right.
right or left? Right. Okay. So right meaning what? X 0 to where? Where does it go to? The line, where does it go? Where does it end? Infinity.
Infinity.
So the interval will end at infinity. Okay. Now, if you look at the other side, you will see what? I see the interval for which the derivative is 0 is to the left. Okay. So where does it start? It ends at 0. Okay. And then it starts from negative infinity. Okay. So here you have two intervals. One is 0 to infinity. That means the right side of the graph. And then the other side is from negative infinity to 0 on the left side of the graph. So if I show you here, it will be what? For the black line, will be up to here. Okay. And then you have another interval going that way. So you got negative infinity to 0, 0 infinity, and the breakout point is 0. So 0 is the critical point. So therefore 0 is not inclusive or is not included in the intervals. So that's why you have the sign bracket like that. Okay, because the 0 is not included. So if the 0 is included, then the interval would be what? Would be like this. Okay, you include the 0, you put that thing, that sign. So here interval, all right. If the interval you include this kind of sign, that means it's included. The endpoint is included, but we don't do that because 0 is where the slope is equal to 0. So you don't put that 0. Okay. So what I discuss here is that the breaking down point would be based on what? Based on where the f prime is equal to 0. Whatever it is. Here is just example where x equal to 0, right? And then you will have, or you can break down the function into intervals for which f prime bigger than 0 or less than 0 and f prime less than 0. All right. Okay. Now look at the second line, the one that I draw in red. Okay. Now if I look at the line I draw in red, blue line. Okay. The black line we already discussed. Now look at the second function here. The critical, the point where the slope is 0 is at x equal to 0. So that would be where you break out the interval. So to the left of x equal to 0, what can you say about the derivative or the slope at the point? Here we're talking about this line here, the blue line. To the left of x, to the left of 0. Yeah. What can you say about the derivative? Think what?
More than 0.
More than 0. So the slope here is positive. All right. What about the other side?
Less than 0.
That's negative. Okay. So it depends on the curve. So that's why you need to know, all right, which interval the slopes are positive, which interval the slopes are negative, because it depends on the function. Okay. So if you look at the blue line, you will see a different situation than our first example. So for the second function, all right, the blue line, if I can draw it here. So for the blue line, okay, go back to the blue line. The point where the f prime equal to 0 is still the same, x equal to 0, but the intervals are different. So for the y prime bigger than 0, it from negative infinity to 0. And then for the y prime negative, it is from 0 to infinity. Okay, all right. Now, the f prime will not always be happening at x equal to 0. It can be anywhere. Okay, it can be anywhere. So I will draw you a few more curves, examples to see it. Suppose I have the following. Okay, suppose y prime equal to 0 here at x equal to 5. All right. Now, tell me, okay, tell me the intervals first. You know the y prime is x, the y prime occur at x equal to 5. Okay, f prime equal to 0 at x equal to 5. All right. So now, what are the intervals for which the derivative is positive, derivative is negative?
Positive is from negative infinity to 5.
So if you look at here, okay, you break out into two, into the behavior of the slopes. So you see here, what? Slope is positive. What about here? Okay, slope is negative. So you'll see f prime bigger than 0, and that will happen from the interval negative infinity to 5. And then f prime negative 5 to infinity. Okay, so you don't have to worry about the shape of the curve. Okay, you just break out into intervals for which the basis of the breakdown will be f prime equal to 0, and then you will have the interval. Okay, all right, I draw you another one. So now, okay, we have the general idea. Okay, general idea. I want to give you just the general idea. So what you do, you don't have to remember. Okay, you look at the curve, you just sketch it. Okay, I draw you another one. Okay, so we got y equal to f of x. Okay. Now let's say I just want to consider, all right. So suppose here y prime equal to 0. This is at negative 10. Here f prime or y prime equal to 0. This is at 15. All right. So now I want you to draw the graph. Okay. I want you to determine the intervals and then determine for which interval the function, or not the function, the derivative is positive, and which interval the derivatives are negative. Okay? Okay, do it now. Okay, number one. The basis of the interval is y prime equal to 0. All right. So, how many intervals will you have here?
4.
4. 4 intervals. Okay, let us see. One is from the left here up to -10. Okay, that is interval number 1. Now, what is interval number 2?
-10 to 15.
-10 to 15. All right. And after that, what is the other interval?
15 to infinity.
15 to infinity. So, how many intervals are there?
3.
3 or 4?
3.
3 there. Okay. So here you can see from the left. All right. You see from the left, the derivative here is what? First interval from negative
Greater than
infinity
0.
to -10. F prime is what? Positive. Okay. Now from -10 to 15. What can you say about the what can you say about the slope?
Negative.
Less than 0.
Less than 0. Okay. And over here, what about the slope? The derivatives?
More than 0.
More positive. Okay. So as I said earlier, the breaking down of the interval will be where the f prime equal to 0. Okay. And then you break out into intervals. It can be 3 intervals, it can be 2 intervals, it can be 4 intervals. And then for each of the interval, we can see, or you have to see, or you have to find, or you have to determine what is the f prime. What is the behavior of the f prime? Okay, is it negative or is it positive? Okay, all right. Now, generally, okay, the critical point can occur anywhere. Well, not critical point. I shouldn't say critical point yet. The point where the y prime equal to 0, it can occur anywhere. Okay, so if we can say that, okay, suppose in general, suppose the given, okay, given y equal to f of x, and then we have y prime equal to 0, say at x equal to x0. So this is a general situation. So the x0 would be basis of our interval. So the intervals that you have will be what? Will be from negative infinity to x0 to infinity. Okay. Now suppose you have 2 points where the y prime equal to 0. Say x equal to x0 and x equal to x1. So here, how many intervals do we have?
Three.
Break out the intervals. So the interval will be what? Negative infinity to x0. Of course, let me say x0 only less than x1. Okay. And then from x0 to x1, and then x1 to infinity. Okay. So from here, okay, I'll give you another one. Suppose there are 3 critical 3 points where x equal where the f prime equal to 0. Suppose x0, x1, x2. So how many interval would that be?
4.
4. So the interval will be just one more than the point where the y prime equal to 0. And y prime equal to 0, okay, where the point y prime equal to 0, we call it, let's say at x0, y0, we call it critical point. Okay, critical point. X0, y0, critical point. But sometimes you just consider the x0 order. Okay, the x is more important than the y. Of course, that y important, but in order for you to break out in interval, you need only the value of the x. Okay, so if there are 3 critical points, there will be 4 intervals. If there are 5 critical points, there will be 6 intervals. So interval is just one more than the critical point. All right. Okay. So that is the signs of the y prime. Okay, and then you can break out into intervals. Okay, next. How does the y prime relate to the function? So now you know already the interval. Okay, you know already the interval. The y prime less than 0, the y prime bigger than 0. So now, if, all right, the y prime equal to dy dx is less than 0, then what happened to the y? Okay, let's say at x equal to x1, the y prime is less than 0. Example, say y prime equal to -5. Okay, then what happened to y prime? To y? Okay, let's look at example. Look at the graph. Okay, I'll give you this one first. Okay, I think I will look at this graph. So let's say, okay, at x equal to x1 at this point. X1 here is 0. Suppose this is 5. And you know the derivative at x equal to x1, for example, 5, the y prime here is what? Less than 0. Say y prime equal to negative, berapa tadi? Did I say, did I give you a number? -5. -5. So y prime is equal to -5. Or coincidentally, x equal to 5, the y prime is -5. So what is the behavior of the y? There. What can you say about the function? At x equal to 5, or at x equal to any point x1, the derivative is negative. Okay? Now, if the derivative is negative, if x increases by 1 unit, what happened to the y? Go back to the slope. If the delta x, if the x decreases by x equal to x1 or 5, x decreases by 1 unit, or there is a small decrease in x. Now the derivative is negative. What about y? Will y go increase or will y decrease?
Decrease by 5 units.
The y will decrease. Okay. So the point here is, if at any point the slope is negative or the derivative is negative, then what about y? What about the function? The function will decrease. The value of y will decrease. It comes from what? It comes from the definition. If x increased by a small amount, what about y? Y will decrease by a certain amount. Or if you want, you just say 1 unit. If x decreases, if x increases by 1 unit, what about y? Y will decrease. So here, example -5, so y will decrease by -5. So what can you say about the function? The function is decreasing. Y decreases. So that is another point. So at x equal to x1, y prime is less than 0. So in other words, you will see here at x equal to x1, the y will what? Will decrease. Okay, well, we'll go down. Why? Because the slope is negative. All right. Now, let's say at x equal to x2, okay, and you know the y prime is positive. I go back to the graph. Here, x equal to x2, y is positive. So I take this point. So we call that point x2. Okay, say this is 15, this is 30. Okay, that point x equal to 30 here. Now, you know the f prime is positive here. So what about y? Will y decrease or will y increase?
Increase.
Y will increase. Okay, so if the derivative is positive at that point, y will increase. Example, say at x equal to 30. Okay, I refer to the graph. Okay, say y prime equal to 7.5 positive. So y will increase. Y will go up in value. All right. So here is the relationship. At any point, okay, at any point when the y prime is negative at that point, you will see the function is decreasing. If the derivative at that point is positive, then what happened to the function? The function will increase. Okay. All right. So this is we can generalize, okay, the idea to interval. Now, in one interval, okay, in one interval, let's say I go back to this graph here. I got this point where y prime is negative, the function is decreasing. Okay, y decreases. Okay. Now, if you look at the y prime negative for the whole interval, okay, for the whole interval, negative 10 to 15. What can you say about the y prime?
Less than 0.
For the whole interval, all right, for the whole interval, the value or the behavior of the y prime is the same. Okay, so for the whole interval, the value of the y prime would be what? Would be consistent, would be the same. If the y prime is positive, then for the whole interval, what would be positive? So in other words, if at one point, if, okay, let's say you consider one interval, negative 10 to 15, all right, and then at one point, okay, at one point, x equal to what? X equal to berapa tadi kita buat ni? X equal to 5. X equal to 5, which is in that interval. So at x equal to 5, and you know 5 is in that interval, all right? And then x equal to 5, I know the f prime is negative. So the f prime will be negative for the whole interval. If you know one value at one point, okay, in the interval is negative, then the derivative for anywhere, okay, for any point in that same interval will also be negative. All right? Or you can, you know, it can work also the other way around. If that one is easy lah. If in the interval you know the derivative is negative, that means at any point it will be negative. Okay, so the other way around is very, very straightforward. But this one, we can only we can know, all right? We can know, or we can have information about the behavior of the function in the whole interval by just looking at what? By just looking at one point. Okay. At one point in the interval, the f prime is negative. That means what? That means over the whole interval, the f prime will be negative. Okay. Is there any question? So if, you know, at any point in that interval, so if I look at another point, another interval 15 to infinity, Okay. Now let's say at x equal to 20, f prime is positive. Say f prime equal to 10.1. Okay, and 20 is in the interval. So what can you say about the f prime in the whole interval?
Positive.
Positive. So for the whole interval, f prime is positive everywhere. Okay, for the whole interval. So f prime will be positive at any point. Okay, at all points. Okay, at all points in the interval. So if we know, okay, at one point in the interval, the f prime is positive, then for each of the point in the interval, the f prime be positive. That means the f prime for the whole interval will be positive. Okay, all right. So what I was saying is that for one interval, say A, B, okay, it's either f prime positive for the whole interval or f prime negative. All right. And then how do we know? We need only to check. Okay, check one point. Just like a test point. You just take one point in the interval. Okay? Just take one point in the interval. And if the derivative at that point is positive, then f prime will be positive for the whole interval. If at that one point the f prime is negative, the f prime will be negative for the whole interval, for every value or every point in that interval. Okay. All right. I think I confused many of you. Are you confused or you are not? Huh? I'm asking you a question. Anybody get confused or nobody is confused? Huh?
Alhamdulillah, so far okay.
Okay, good. Now, if you are confused, that's good. Okay. If you are confused, that's good. If you are not confused, good also. Okay. So if you are confused, that's good sign. That means you are learning something. Okay. So if you're confused, that's good. So what I want you to do tomorrow or tonight before Wednesday class, you go and review everything. Okay. Review everything, see whether it makes sense or not. Put everything in perspective. And Wednesday, we will continue. Okay. All right. If you are not confused, that's good. If you're not sure, then that's not a good sign. If you are confused, that's good. So that means we learned something. Okay. So you go home, put everything in perspective. Tomorrow or Wednesday, I will continue from there. Okay. All right. Any question? Anything?
No, sir.
Okay. Good. So I will see you again on Wednesday. So make sure, I want you to go home, spend some time, review everything here. Okay, so Wednesday, we will make it more formal. All right, what we do today is a general idea. Okay, so we want to put into a more formal way, and then we can come up with the first derivative test. Okay, all right. Have a nice day. I will see you again on Wednesday. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Waalaikumsalam.